Well, hello, everyone. Welcome to our August Exchange Cafe. This will be a follow-on to last month's session concerning system of systems challenges led by Beth Wilson. Last month's cafe began with a summary of system of systems challenges when it comes to defining needs and requirements and verifying system meets the requirements and validating that system meets the needs. After the presentation, the session was opened up for a general discussion concerning system of systems. What is common to systems and system of systems, what's unique for a system of systems. A recording of this presentation is available on the INCODE Requirement Working Group YouTube channel. During this meeting, we will kick off a project to develop a system of systems guide that tailors the Requirement Working Group products, including Needs and Requirements Manual, the Guide to Needs and Requirements, and the Guide to Verification Validation to address the unique challenges for the system of systems. Links to Beth's presentation are put into the chat, as well as a paper describing more detail on the WAVE model that she will be discussing. A little bit about Beth. She earned her PhD in electrical engineering from the University of Rhode Island. She's retired from Raytheon, where she worked for 33 years as a design engineer, program manager, research scientist, functional manager, and test director on sonar, satellite, and radar programs. She's a Raytheon certified architect and certified Six Sigma expert. She's currently an adjunct professor at WPI in their Master of Science in Systems Engineering program. She's a INCODE ESAP. She's chair of the INCODE Certification Advisory Group, co-chair for the INCODE System Security Engineering Working Group, a member of the System of Systems Working Group and the Requirements Working Group. Upcoming events that we have planned for the rest of the year. In September, we'll have another Exchange Cafe with the general discussion focused on anything about interfaces. In October and November, Beth will switch gears from system systems to system security challenges and how to develop a system security guide based on the Requirement Working Group products. On December 14th, Henry Matfork will give a presentation, Configuration Management Across the Digital Thread. And this is a follow-on to a presentation he gave at IW 2022 as part of the Requirement Working Group sessions. In January, for IW 2023, we plan on having 2 days of sessions the week before IW. Then during IW, we'll be having collaborative sessions with other working groups. Most likely, we'll have a joint session with the System Systems Working Group and also a joint session with the System Security Working Group, and then any other working groups that want to have a joint session with the Requirement Working Group. And with that, I'll turn the session over to Beth.
All right, so as Lou mentioned, this is kicking off a new project. When we talk about the Requirements Working Group products, we have the Needs and Requirements Manual, we have the Guide to Writing Requirements, we have the Guide to Needs and Requirements, the Guide to Verification and Validation, and then we have this other area of other domain-specific guides. And what we're looking to do is to kick off this project on a guide for system of systems and how they would use these products. And we're also going to start one on system security, the idea being that by having two of them going at the same time, we might be able to develop a useful format that other working groups could come in and say, well, I want to tailor the Requirements Working Group products to my domain, and then we would have something that works for two working groups, so it would be more likely to work for theirs. So the topic of this is, how does the System of Systems practitioner use the Needs and Requirements Manual and the guides that flow from it? Just by way of summary for those that either didn't attend the last session or forgot about it in between, the System of Systems definition is in this package. And the key thing I want to make here is that it's a collection of independent systems. So the constituent systems in a system of systems are systems themselves. Okay, so they independently deliver unique capabilities, and then the system of system represents the synergy of those constituent systems working together. And then we had types of system of systems. So directed is actually quite rare. That's where you have a system of systems organization that has authority over the systems. We see this in things like some transportation systems when they're laid out. There is somebody that's able to create the system of system and has authority over the constituent systems. Most of the system of systems that I've seen are acknowledged, meaning that the systems have their own management, their own funding, their own authority. They work in parallel with the system of systems. And so the changes are based on an agreed upon collaboration. An example of an acknowledged was air traffic control, the fact that we have air traffic control systems, we have airport systems, we have airplane systems, and their interaction is typically acknowledged. Collaborative is when it's not centralized. There's no system of systems architect per se, but rather that the systems decide how to interoperate with each other to achieve system of systems goals. So we see this, for example, in the electric grid. And then we have virtual. That's where the systems interact, but they don't even know about each other. And changes occur as the systems change. And the internet is a good example of this. Okay, so we discussed some of the pain points, and the two that I want to remind you of are the capabilities requirements pain point. This was identified as an issue because each constituent system has its own capabilities and its own requirements. And so the system of system needs may not be consistent with the constituent systems. And so it means that the system of systems team and what we want to bring out in the system of systems guide is that their responsibility is to translate the system of system end-to-end capabilities into a requirement set for the constituent systems. And typically they're not allocating requirements to systems as much as they are identifying what constituent systems might be able to satisfy requirements, and they will add them or take them away from the system of system as it evolves. And then the testing pain point is that it's difficult to tackle verification and validation when your constituent systems are coming into play and evolving at their own pace. So you have this unsynchronized development cycle. It complicates the test planning, but also the scale and complexity of end-to-end testing makes that prohibitive. So what we've been doing is engaging in modeling and simulation to reduce testing costs, and really looking at modular architectures to reduce the propagation when we make changes to a constituent system. And then we also talked about core elements of system and systems engineering. And I bring these in because I think it's important to recognize that the system of systems activities are these core elements. So they're trying to understand the capability objectives, looking at high-level capabilities, and then trying to figure out if constituent systems can currently provide capability that would meet those needs, or do we need to ask for changes to the constituent systems to meet those objectives? I want to point out one other is the developing and evolving a system of systems architecture. When we talk about a system of systems architecture, we don't mean the way we think of a system architecture where you're describing how all the design details that are part of the system of interest. In a system of systems architecture, what we're doing is defining how the constituent systems work together. So it's more about the interactions of the constituent systems. Okay, so these are the core elements of the system of systems engineering. One of the things I did not bring out in the last cafe session that I wanted to bring in today is this paper that Lou gave you the link to. It's the implementer's view of systems engineering for system of systems. And we call this the wave model. The idea is that the systems are evolving or being developed at their own cadence. And then within the system of systems, we're thinking about the revision of the system of systems as waves of capability. So increments that happen as we look at the system of system analysis. We do the analysis of the capabilities. We look at what the constituent systems are capable of doing to support the system of system goals. And then we're evolving that system of system architecture that defines the interaction between the constituent systems, and then planning the next update and the implementation. When we say implement the SOS update, that's where we bring in the verification and the validation. And so this maps to the swim lanes you see in this are the core elements. The names changed a little bit since the 2010 when the core elements were defined in the 2011 paper, but you get the point that there are activities in this wave model that map to those core elements. Okay. And so the artifacts that are defined in that paper, and there's also some information about it in the SOS primer, these are the different things that a system of systems team is going to be generating. So when we talk about the ConOps, it's not the same as the ConOps we have for a constituent system. It's describing how multiple constituent systems are going to be used and evolve over time to satisfy the system of system goals. When we talk about requirements as a system of systems artifact, we're talking about a requirement space, not specific requirements. And we define them at a level that allows us to trade among potential and actual constituent systems. So it's not the same allocation of requirements that we think of in systems engineering. And then the architecture, as I pointed out, was defining how the constituent systems work together, not the system details of the system of system, but actually the end-to-end functionality and the data flows and the communications between the constituent systems that are selected to be part of the system of systems to meet those goals. And when we talk about a technical baseline, that's a system of systems level description, and it identifies the pieces of the constituent system baselines that are part of the system of systems. I think it's important to remember that constituent systems are systems themselves. So the capabilities they have and the requirements they manage are not the same as the system of systems. There may only be some capability that that system has that contributes to the system of systems. So they may have other activities that are not part of this system of systems. And then when we think about the wave activity, that wave model, these are the different activities and what the purpose of each of those activities are, and then what system of systems artifacts are going to be generated or updated in each of those phases. So when we talk about conduct system of system analysis, that's analyzing the as-is system of system, that's establishing the basis for system of systems evolution. And what I want our system of systems guide to do is to translate for a system of systems practitioner who knows that conduct system of system analysis is to analyze the as-is state and establish the basis for evolution, to be able to show them what that means in the needs and requirements manual, what that means in the guide to needs and requirements. And when we talk about implementing the system of systems update, where we're implementing the constituent system capability and we're conducting the system of systems level integration, verification, and validation, and we're establishing a new product baseline, what I want to be able to do is say to a system of systems practitioner, here's where you find this activity, here's where you find these system of system artifacts in the needs and requirements manual and in the guide to verification and validation. So the discussion here is, where does system of systems engineering fit on this graphic? You know, how can we translate this graphic to resonate with a system of systems practitioner? My fear is that a system of systems practitioner will open up the requirements working group documents and look at something and say, that doesn't apply to me, and close it and not use it. And there's valuable information in these products that if we could just provide the Rosetta Stone, if we just provide the translation, they would be able to see themselves in these documents and be able to use them as a tool for system of systems as well. So, you know, for example, where we have this realized system of interest for the system of system practitioner, that is the system of system. And so, you know, what I wanted to open up for discussion is, how do we organize the manual? Do we talk about all of these activities that are on this graphic? Do we talk about them as how they apply to the different types of systems of systems? Or do we turn around and say, this is how they apply to the core elements? Or do we turn around and say, this is how they apply to the wave model and the artifact? So that's what I wanted to bring up. I'm not sure what's the most useful slide to stay on, but I want to open that up for discussion. So thoughts, comments, advice, preferences? Before we get into that, Lou mentioned that I had some goals for this guide. I'd like it to be a standalone guide that is less than 100 pages. And I would like it to be something that maps to a system of systems implementation and translates the requirements working group products to system of systems practitioners, starting with the guide to needs and requirements, that kind of approach. And then what I wanted to do today is really brainstorm what would be useful to a system of systems practitioner, and what's the potential structure and approaches. And when we have hopefully that will get some of you excited enough that you want to join a project team to be a contributor, to be an author, to be a reviewer of this guide as we make progress on this project. So Lou, what's the best way to handle this from now? Should I keep sharing, or should I take it off and open it for discussion? What would work the best?
Maybe what we could do is I could show some of the slides that we discussed earlier.
Oh, yeah, that would be good. What Lou and I were doing was we were looking at what some of the things that are in the needs and requirements manual that are relevant to system of systems, but we may just need to be, provide a little translation for it.
I have a general question.
Yeah, go ahead.
All right, so it is requirements based. I'm working on system of systems, kind of like a space station program. I kind of define levels of requirements just so we can get a handle on what kind of documents we're looking at. And then as we go to SRR for each of the subsystems, the systems within the system, what type of a level requirements you're looking at. But going from a straight like level 0 down, it looks strange to the embedded systems because they're used to seeing like, oh wait, these are level 1 or 2, but in the terms of the grand arcing scheme of things, it is down that far because it's, pretty far down the system hierarchy. So I was just wondering, is there like a good way of doing that where you could alleviate confusion or clear defined levels of requirements when you're working for system of systems?
Well, what do you mean by levels of requirements? I think the main difference is we're talking about capabilities and requirement sets. It's not the doors database as much as it's a capability.
Yeah, and that's what I mean. So thanks, Lou, for bringing this up right here. Yeah, so when you're talking about, like the level 0, 1 requirements, and that's kind of like the capabilities you want the system of systems to do, the overarching, what you're trying to get out of what capabilities. I want a space station in Leo orbit, right?
Mm-hmm.
But if people are used to seeing like, oh, okay, that's level 1 because that's the first level in the hierarchy of items, and you drill down, so what people are usually seeing, oh, I'm making level 2 requirements, they're getting confused because wait, that's actually like the 5th level down because it's, they're pretty deep into, if they just look at the hierarchy straight up. So just wondering if y'all thought about that, or is it, or I'm just making it harder than what it is and I just need to talk to my team.
I don't want to introduce something that's a higher level. The slide that Lou's showing right now shows how a system of interest, how it would progress through the life cycle, and at what points would it interact with subsystems that at the subsystem level, they're a system of interest. And so we can turn this around and say, well, if the level 2 is the system of systems, then the level 3 is a constituent system. And we don't need to know any more details below that.
So when you look at the 15288, it describes the different processes. They talk about basically different organizational level requirements, which are level 0 and 1. So they own the problem and the whole reason for being a system of systems, and they develop high-level concepts, classes of solutions, and so on. And then a project team is formed to develop the system of systems. And so in that case, there's going to be higher level requirements from whatever organization has a need for the system of system. And those are defined in the level 0 and 1 on here. And then the system of system would be level 2 definition. And then level 3 in this diagram would be the constituent systems. And then like Beth said, the level 4 from a system of systems standpoint is fairly transparent. The system of systems practitioner shouldn't be really worried too much about the level 4 part of the constituent systems. Mainly, what does the constituent systems need to do to be part of the system of systems? So if you look at a constituent system's complete set of requirements, they're going to have a whole lot of requirements dealing with what their intended use is as a standalone constituent system. But then the system comes along and says, hey, we'd like you to support what we're doing also. So there's going to be a subset of requirements allocated from the system level to each of the constituent systems. And that would be what we would manage, would be those. The constituent systems, because they're being managed and funded and everything as a separate entity, now they're given these extra requirements on top of what their requirements are. So now they have to assess, how can we support the system as well as continue to do what our intended purpose is?
Yeah, and Lou, one of the things that we may even need to be careful about the language, because what we have in the guides right now is that you develop the integrated set of needs, and then you do this requirements definition. And what you're showing in this graphic, you then allocate requirements to the subsystem. And in the system of systems, you don't really allocate requirements to a constituent system as much as you identify a constituent system that has a requirement set that supports the system of system goals.
It seems like you kind of do both. It's both a top down and bottom up thing.
Well, it is top down, but just the language of you identify who has requirements that support your goals, because you may not have the authority unless it's directed. You don't have the authority to allocate requirements.
I was thinking from a system standpoint, I know I have some things I need from the constituent system. And then part of the lifecycle concept analysis maturation is to do an assessment of how well each consistent system as it is can meet my needs.
So that's a good example, though. That assessment of as is, where do we find that in the requirements working group products? And so that's what I think would be useful in the guide. And I ask you, Lou, because you know where everything is in your 457 pages.
Okay, so basically it's here. So if you think of the system of systems, they need certain data and information. And so each of these circles represents different activities they need to do to obtain that data and information. The higher level needs, higher level concepts, higher level requirements can come within their organization concerning the system of systems. When you get into lifecycle concept analysis maturation, then in there, you're going to be doing those architectural things you talked about. You're going to identify what the constituent systems are. You're going to identify then what role they play in meeting your goals and objectives. And then you're going to start thinking about how they're going to interact to do that. And you may have to go through several cycles of analysis to come up with a workable architecture as you defined. In the manual, that's what we talk about, going through several cycles of analysis and zeroing in on when you eventually will end up with what you think a concept for the system of systems that will work, given the constituent systems you have. As part of that, you may find that there's deltas. We want 12, but they can only give us 8. And then as part of our concept, and that's where the wave model comes in, is saying, okay, we'll start out with 8, but we'll have a plan to maybe how we can get to 12 performance-wise.
Right. And looking at this diagram, I would see a translation where, you're saying you have a preliminary set of life cycle concepts, and for the system of systems practitioner, I would probably translate that to defining an initial system of system capability. So those capability objectives, that might be what we're talking about there. And then the trade space to define physical architectures, that trade space is to identify constituent systems that can support the SOS goal. So it may just be a matter of identifying the right words so that the same concept applies. And that's what I mean by translating for SOS practitioner.
And that's the intent of the manual, is to provide an underlying framework that then individual domains can tailor to their needs and translate the language. The Rosetta Stone, start using this, maybe different terms for the same underlying concepts.
Yeah, so that's where I get that Rosetta Stone, the language translator. When we start brainstorming what this might look like, one of the things that we can think about is it taking these kind of diagrams and translating them? This is what appears in the needs and requirements manual, and this is how we translate it for the system of systems practitioner. this is something we see in the guide for needs and requirements, and this is how it resonates with the system assistance practitioner.
Beth, if I understood you correctly, so as a system assistance practitioner, I'm not expecting my requirements to derive other requirements. I'm building a set of capabilities that I guess subsystems, lower level systems will be allocated those capabilities, since that they'll be selected to satisfy the capabilities I defined as a SOS practitioner.
Yeah, we'll look at a constituent system and see what performance they have, what capabilities they have, and then we will select that constituent system to provide that capability to support the system of system goals.
And is that still the same applicability to like systems that don't exist yet? So you're kind of developing all the constituent systems along with.
Yes, some of them may exist. And then as you do the analysis of the as-is constituent systems, that system of system analysis provides the gaps. And in the gaps, you say, okay, do we need to develop a new system? Do we need to negotiate with another entity to have them update their system to fill that gap? That's what the system of system engineers are doing.
Maybe there is no constituent system that fits my needs for the system of system, and I have to develop a new system. Is that really a separate entity then? Or is that part of my system of systems from a traditional system standpoint? Is it dedicated?
Well, no, you would be going out and saying, we need to have a new constituent system developed that can provide this capability that's missing.
But are you the sole user?
Probably not.
If they don't exist, then they're created just for you.
Well, it may be, but typically what I've seen is in a directed system of systems, you do create constituent systems that were designed solely for the purpose to support the system of system goals. But then what will happen is they will then be repurposed in different situations. Then that will become a constituent system in a different system of systems. So it may be designed first for one purpose and then modified for a different purpose. Yeah, remember, a constituent system operates on its own.
Yeah, that was what confused me is one that was developed solely for my system, then it doesn't seem like it would fit in that definition.
Well, and that's why the GPS case study is so interesting, because that was a directed system of systems when it started. And so all of the satellites and the ground stations and all of the systems were designed to support the GPS system of systems for a military purpose. But then it evolved and then it became acknowledged as different. Oh, well, you got that GPS. Well, I can pull that into my system of systems and I'm going to have it for a different purpose. And then it became collaborative, where we started having commercial use of it. And now it's virtual. The systems don't know anything about each other. My Garmin watch that is supposed to help my golf game was not a directed system. It's a constituent system designed with a different purpose that happens to work with the GPS. So Carlos, what do you mean by before we highlight ontological differences and then, oh, you're mapping to I'm looking at the chat.
Yeah, I don't know if I can interrupt. I'm trying to answer to your question. I hope it makes sense in this point of a discussion. For the system of system practitioners, one of the very first thing is to understand well the characteristics, so the ontological characteristics of their system of systems. So it's what is indirected, acknowledged, collaborative, or virtual. So I would start from that to clarify what system are you dealing with. And then once you understood the differences, that is the wave model, if I understood well, and the artifacts that are the how and the what of the system of system. Is this way of thinking reasonable or?
Oh, yeah, that makes sense.
Okay, I hope I didn't misunderstood. Okay.
Yeah, I was missing what the numbers were. So you were referring to before mapping activities to a type of SOS. And the more we talk about it, the more I'm not sure it's important to make a distinction between types of SOS. I think it would be better to map to the core elements and to bring in the artifacts, and I think what might make sense would be to have this list of system of systems terms and how they translate to what we already have in the requirements working group product. So for example, when we talk about a system of systems architecture, it's not the same as a system architecture. And when we talk about a system of systems requirements, we're talking about a requirement space, and it's different than, so we can make those distinctions between, you're not going to allocate requirements, but rather you're going to look for constituent system requirements space that supports the system of system goals.
So with the core elements, you mean, for example, one of the core elements are the needs, for example, and then the requirements. Is that correct?
So yeah, the core elements, there's 7 of them. Understanding the capability objective, understanding the systems and relationships, assessing performance against capability objectives, developing and evolving system of systems architecture, monitoring and assessing change, addressing requirements and solution options, and then orchestrating upgrades. So they're the ones that you see in the SOS primer.
No, okay. Makes sense. Sorry, I didn't, I couldn't follow well the presentation before. And yeah, makes sense to go through because the core elements are general and they should pass over the distinction among the different types of system of systems. Yeah.
Right. I think it would be important to address the core elements because those are activities that the system of systems practitioner is familiar with. And if we could translate these to, okay, when we talk about this particular activity and this focus, you will find that in the needs and requirements manual in, when we were talking about identifying the constituent system functions and data exchange, where do we find that in the manuals? And I think we also want to be able to translate what these artifacts mean and how they're different. When we talk about ConOps in the requirements working group products, it may be different than what we're talking about in the system of systems ConOps. And so, we can provide that mapping, I think is the best way to put it. And then the other idea would be to look at the SOS wave activity. I was originally thinking we would do one or the other, but I'm actually starting to lean toward it might make sense to do both because the practitioner may be familiar with the wave model or the practitioner may only be focusing on one aspect of one of these core elements.
Yeah, I fully agree. It's difficult that there is one person that is dealing with all these aspects, or as a general view, in case of system of systems, all these aspects. Too many persons, too many organizations involved.
Because some of them are one-to-one. When we talk about the implementing the SOS upgrade, that's orchestrating the upgrades. I can see you're coordinating changes, but in the wave model, it's described as much more than that. It's described as actually doing the test and evaluation and establishing the new product baseline. So we may find some combination of that. And then what I was trying to think, do we take the system of systems activity and map it to the requirements, or do we take the activity that we see in the needs and requirements manual and map it to the system of systems entity? I'm not sure which is going to be the best way to go about it.
It seems to me that a large part of the upfront work for the system of systems is actually covered within the lifecycle and needs definition activity.
Well, so that may be another thing that we need to think about is that are there areas that we're looking at that are more significant to the system of systems practitioner? I would argue that they would go through all of these process steps and that they would do design validation, system validation, that all of these make sense to system of systems, but there may be some that are more important than others.
The part of this diagram that bothered me a little bit from a system standpoint is that the design output specifications are actually defining how the constituent systems are actually built.
Right.
In the system systems view, that's that layer underneath where we need to think about. The design input requirements are really what are the requirements that the system has to meet. Some people call that a functional baseline. And then the realized system of system is all those constituent systems integrated together for the purpose of meeting those requirements for the system of system and being able to validate against the needs for that system. I think that's one big difference, is that from a system to system standpoint, we're not really thinking about actually engineering the constituent systems.
Right. It's almost like the design output specifications becomes this dotted box. And the architecture and design definition for a system of systems, the architecture and design definition is saying how these constituent systems will work together that you've selected.
I think I kind of disagree with you when you say we don't allocate requirements, because the system itself is made up of the constituent requirements. So at the top level requirements for the system, I have needs and requirements, but then I have to decide through allocation, what role does each of the constituent systems play in meeting my requirements?
So I agree with you there. I do agree that realistically, yes, we do allocate requirements to a constituent system. I'm just trying to tone down the verb because we may not have the authority to allocate. It's like the difference between assigning a requirement versus inviting a constituent system to accept the requirement.
So would that be more the concept of an MOA or MOU, where at the system systems level, I've identified I need certain capabilities from a constituent system. I need this functionality. I need.
Right. So that transformation would be those agreements, those contractual agreements. Yep.
So would that also include like a SAL?
It's not a statement of work, because it's not a statement of work to the constituent system. The constituent system has its own statement of work for whatever it was designed to do. It already acts independently.
But you wouldn't have the statement work like constituent system owner shall meet all requirements or capabilities or needs.
Yeah, I could do that and direct it, but in acknowledge, I'm just generating agreements. And in collaborative, there's nobody to issue the shalls. There's no system of systems team. All the constituent systems are collaborating. Instead of through agreements, they typically do it through standards.
So there is a difference then between the different types of system to system. So in directed, we have some control. We can actually do allocation to those other organizations, and we could issue maybe even a statement of work and needs and requirements. But if it's acknowledged, then mainly what we can do is have a MOU, memorandum of agreement, that would include some things we'd typically put in the statement of work, because we're talking about roles and responsibilities and capabilities provided. So we're thinking about both people, process, and product, and we would have to define all three of those within the MOU. And so the design input requirements here, we would relabel those to be more appropriate for a system of systems. At the top level, this is the system of system requirements. And then you basically go from there to the realized system, because the constituent systems are already built, theoretically, in this case.
Or they will be built under different premises. So the design output specifications becomes this dotted box that the system of system practitioner doesn't pay attention to. That's done behind some curtain. So it's almost to the point of being NA. It goes right to the realized system of interest.
Which includes all the constituent systems.
Right.
One of the things I understand is this diagram applies to a single system of interest. If you looked at a hierarchical diagram, for every part of the architecture, you would repeat this diagram.
Right.
So this diagram exists for each part of the architecture. So in the case of system of systems, we would define this for the system of system level, and then each of the constituent systems would have their own version of this.
Right.
Which would be more traditional.
Right. Oh, that's true.
Yeah. So I think going back to your goals for the guide, it seems like one of the big things is to do a transformation of ontology of language between what the requirement working group products and any given domain. So in case of system systems, we've identified some areas that we have to change the language. Architecture is different. The definition of allocation is treated differently. So there's certain key things. Requirement space has a different meaning. It really is our lifecycle concept and needs definition space. And so we have to, do that translation. So their system system practitioner, they're reading in their language. They're not having to read a different language and try to translate that into their language. We need to communicate the guide in their language.
All right. No, I think you're right. What I'd like to do now is ask the people that are in there, if you can put in the chat, are you interested in being on this project? If so, would you want to be a contributor, giving us some things that we can use to develop this, to be an author on one of the sections that we've highlighted that we need to include, or a reviewer when we've got something to look at? So I'm inviting you to be part of the project team to develop the draft. All right, so what do you think of the project? Does this sound like something that's worthwhile that we should be pursuing?
Absolutely, it is. I think that everyone that has to deal with an enough complex system fundamentally is already in a system of systems. One of 4 types, but that's what happens in my day-to-day life. And so it's worth having, knowing the differences and how to behave artistic. What are the differences and what could be done in case you are developing one isolated systems or a system strongly or weakly connected to other ones, which are the great majority, not every system in general.
Mark, when you signed on, you said you were getting ready to start a system of system project.
Oh, he just joined the System of Systems Working Group.
Yeah, that's why I joined the working group. I'm fairly new to the program, but it's basically we're in the early stages trying to take the constituent systems, and then there are different life cycle phases and determining all their capabilities and how they're going to work at the system level.
So to me, you're a good candidate to answer the question. You know, the purpose of this new guide is to help a practitioner that's having to work in a system to give them some guidance and a little bit more how than what's in the paper or stuff.
Exactly.
What would you like to see this guide be?
I kind of what I've been noticing from my group is, I guess you can't really streamline the process, but it's like more of a try to figure out like a way to, I like that wave diagram. It makes sense. I think the biggest problem is how we approach and communicate with the various systems that are part of the enterprise. And I think the guide would help. I think that's kind of the biggest issue. And then kind of forums for the systems to kind of understand each other on an interface level is our biggest issue.
You know, Lou, maybe what we could do is between you and Mark and I, maybe what I need to do is send an email to the two of you and say, okay, this is something that the system practitioner has to do. Where do I find it? I can ask you, Lou, where do I find this in the Requirements Working Group products? Just a discussion that we had earlier today. And then ask Mark if that resonates with what he's doing.
Yeah, that would be great. That'd be really helpful.
Yeah, it's interesting. Over the last several months, all the emails I've gotten with people asking me questions, I've been able to point to some place in the manual that had the answer.
Right. Yeah, because I'm not sure I want to set up a bunch of Zoom meetings. I think it might be something to be take one of these translation items at a time, like what we were doing with the as-is constituent system, where we went to the life cycle concept. So that might be a way to just pick one and develop it, and then pick another one and develop it.
I think we could start with the guide to needs and requirements as a boilerplate, and then start redlining it and putting in, taking out stuff, putting in stuff, translating the language that's in it would probably be the fastest route.
Okay.
That way you don't have to start from scratch.
Although I think I may need some more upfront translation.
Oh, no, that's part of the stuff you're going to add to it.
Yeah. All right, I think we got an approach.
Time's up. I want to thank everybody for attending. We'll see you next month. We'll send out the notice. The topic's going to be on interfaces in general. So y'all have a good afternoon.
Thanks.
Thanks.
All right, thanks, everyone.